Pregnancy lengths are normally distributed with a mean of 280 days and a standard deviation of 20 days. 9 months is approximately 273.6 days. What is the probability a woman is pregnant for at least 273? Okay, so a couple important phrases here. The first is that pregnancy lengths are normally distributed. So we know we can use the bell curve to solve the problem. And it says, what is the probability that a single woman is pregnant for at least 273 days, they mean there, right? Okay, so let's draw the bell curve because we heard the phrase normally distributed. So put my little bell curve cut out here. Okay, so on all bell curves, we should label a mean and a standard deviation. So let's put the mean off to the left here, standard deviation underneath it. It says that they have a mean of 280 days, so 280, and a standard deviation of 20, so put 20 here. Underneath the curve, you want to put a z-axis and an axis that we'll call the x-axis. It represents pregnancy lengths. The z-axis has a center at 0, and the average pregnancy length is the center for the x-axis, which will be 280. Okay, from there, we want to put the next number on the drawing here that we're given. It says that 9 months is approximately 273.6 days. What is the probability that a woman is pregnant for at least 273? So let's use 273, which would be to the left of 280. So 273. And remember, that's an X length, right? It's a pregnancy length. It goes below 280 on the number line. And we're looking for the probability that it's at least 273. Now, the phrase at least is the same as saying that it's a minimum of 273, that's the smallest value. So you would say at least 273 means 273 or more, and we will shade therefore above. So above that point is the proper answer. Okay, so we want all the area to the right of 273. Well, I happen to know that this part, the half of the curve from the line over, is 50% of all the area on the curve. So I have that area already. Now, if I could just look up 273, I'd get the area from here to here, and I would be done. Then I would have the two parts of the shaded region, and I add those two parts together to get my final answer. However, we can't look up 273 because it's not a z-score. We only have a z-chart, so we're going to have to convert the 273 into a z-score value. So let's go ahead and do that quickly. Let's say that z is equal to x minus the mean over sigma, where x is the score you want to convert. So we want to convert 273. We'll subtract off the mean of 280 and divide by the standard deviation of 20. Okay, let's see what that gives us. So we have a difference here, of course, of -7, so we have -7 divided by 20. And when we're done, we get a small number, -0.35. 0.35. Okay, so let's put that here, -0.35. And we'll look that up on our z-chart to find the area from this line to the center. So let's go to the chart now and look up 0.35. Okay, so we're going to look up -0.35. There are no negatives, so we'll just look up 0.35 on the table. 0.3 is here, that's the row, and 0.35 gives us the answer 0.1368. Okay, so we find the area to be 0.1368, 13.68. We take those two parts, we add them together to get our final answer. So the final answer would be 0.5 added to 0.1368, and of course that gives us 0.6368. All right, so let's write it out as a probability statement. The probability that a woman is pregnant for more than or equal to 273 days, right? So 273 days or longer is equal to the probability that a z-score is greater than -0.35, and that is the same as the probability 63.68%. Okay, so that is our answer. About 63.68% of all women will carry a child for at least 273 days.